So in this lesson, we're going to look at Ohm's law, and we're going to look at the relationship between these three characteristics or three properties of electricity. So before we start explaining what Ohm's law is, let's go into these three characteristics here. So if we think about electricity, so fundamentally electricity comes from, we have what's known as the electron. And the electron is one of the subatomic particles that makes up atoms. And it has this negative charge, and it is extremely small, so the electron. So it's the movement and flow of this electron that is what gives us electricity, for example, that we use in our home. So in relation to this electron, we have these properties of voltage, we have current, and then we have this thing called resistance. So if we think about electricity, so we have to kind of consider electricity. Essentially what it is it's the movement of electrons through materials that will allow this electron to move through it. So if we take this here as an example, let's imagine this is a piece of copper, so a piece of copper wire. So imagine this is a piece of copper. So copper is like a material, it's a metal that allows electrons to easily move through it. So imagine this is the inside, and in here you have atoms of, so imagine these are atoms of copper. And then around the copper then you have this other substance that is an insulator. So it's like plastic, for example. And this is what you would see on any cable, for example, that's attached onto a plug. So imagine this is like plastic. So plastic is like the opposite of copper. It's a really poor, what's called a poor conductor, or that just means that it doesn't let electrons move through it. So electricity then is basically what happens is, so this is imagine this is an electron, and it moves through the wire, and it doesn't just move like directly through it in a straight line. It bounces off all of the copper atoms that are inside the copper wire. So it'll have a path that's something like this. So it's going to bounce off each of these, and then it's going to go through out the other side. So what's going to happen is when it bounces off each of these atoms, okay, these atoms are going to vibrate. So imagine they're going to vibrate. And when they vibrate, what they will do is they will give off heat. So you have heat. Okay, so you have copper is a substance that allows electrons to move through the wire. So that or another way is it allows electrons to conduct through the wire. And then you have plastic, which does not allow, it resists, it's a resistor, it resists electrons moving through it. So you get this movement as the electrons move through the copper wire, for example, they bounce off all the atoms inside it, and what they do is they cause it to vibrate and they cause it to heat up. So when we're talking about this then, so this is what's happening, if you like, from a physical point of view, but then scientists need words in order to be able to describe this and talk about it. And then even they want to try and come up with formulas then as well to be able to describe this process in more detail. And this is where these guys come in: voltage, current, and resistance. So we want to try and understand like what these mean, okay? So voltage, so what is voltage in relation to the electron and in relation to the material that it moves through? So voltage is like, you can think about it as the amount of energy that the electrons have. Okay, so you can think about it like potential energy. So what happens is if the electron has a lot of energy, what's going to happen is it's going to hit the atoms much harder. They're going to vibrate much more, and they're going to give off, like it's going to give off more heat. So you can think about voltage as like the push, or the push that pushes the electrons through the conducting material. So why does the electron decide to move through the wire like this? Well, it's been attracted by this force, by a positive force from the battery, and that's essentially pulling the electron towards it. So the bigger this positive force, or the bigger this pull, the more energy that these electrons are going to be pulled, the more energy with which the electrons are going to be pulled through the copper wire. So you can think about voltage like that. It's like the push or the pull that's on the electrons pulling them through the wire. And it's measured in volts. Okay, so it's measured in volts. The next one then is what's known as the amp or current. So this just relates to the amount of electrons. So it's not just one electron that's moving through. It's a huge number of electrons that are moving through. So you have like a number of electrons that are being pulled through the copper wire by, for example, this positive force that's pulling them through. And we don't need to know the exact number of electrons, but we can refer to it as an amp. It's kind of like saying a dozen eggs, for example. Well, instead of saying like a dozen electrons, we say an amp. And it's a huge number, so we don't need to necessarily worry about the number now, but just think about it like it's a symbol that represents a particular amount of electrons. Okay, so and it's measured in amps, and so this is measured in volts, and you see it like this, volts, and this is measured in amps, and we just use it like a capital A like this to measure this. And you can think about it like it's like it's an amount of electrons. Okay, so voltage is like the force that these electrons are being pulled through, and amp is like the number of the electrons that are being pulled through. And then the next one then is what's known as resistance, and we measure this in ohms, and it has this kind of weird symbol. It's like a horseshoe. And this resistance is basically relates to the material that the electrons are moving through. So like I mentioned that copper is a good conductor, so copper has low resistance, so it allows the electrons to easily move through it. Whereas if you take something like, so copper is a good conductor, so it's a conductor. Okay, and then plastic then is a poor conductor, so you can say it has low resistance. So that just means it doesn't resist the movement of the electrons. If you think about plastic, then plastic is what's called an insulator. And it has high resistance. Okay, so that means that it resists the electrons moving through the wire. And then we've things that are kind of in the middle, like silicon, for example, and that's what's known as a semiconductor. So it's kind of in the middle of these two. So copper is a semiconductor, so it lets electrons move through, but only to a certain degree, and they're what are called semiconductors. So that is voltage, that is current, and then that is resistance. So now what we want to think about is how do these all relate to each other? So we have a formula that we can use to relate these all to each other, and it's this formula here. So voltage, V, is equal to the current, we use an I to represent the current, multiplied by the resistance. Okay, so that's what we mean by, so it's voltage is equal to current. So remember, I'll just put an I here beside this. Sorry, not an I, we put an or beside this. So this is the resistance part, and then I is the current part. Okay, so put an I here like that. So we have this formula here. So voltage is equal to current multiplied by resistance. So let's look at a simple current. Okay, so simple circuit. So in a circuit you have a battery. So you can think about battery. So it has like a negative terminal. So imagine this is the negative terminal, and then it has a positive terminal. This is like the positive terminal here. And inside the negative terminal, imagine it's like you've loads of electrons. Okay, and then inside the positive terminal, it's all positively charged. Now what wants to happen naturally is the electrons, they want to move from this negative terminal into this positive terminal, but they can't. And why can't they? Because normally inside a battery, you have in the middle here, you have like an insulator. So you have like an insulator in here like so. So imagine this is like an insulating material. So, and this is all like enclosed inside a battery. So you have the negative terminal and then you have the positive terminal. So the negative terminal is full of electrons, and the electrons want to get to this positive terminal, but they can't get there because they're being blocked off by this insulator here. So what will happen then is when we create a circuit, so imagine we take some copper wire and we create a circuit like so, and I'll just put like a switch here so we don't connect up the circuit completely yet. So this is like a switch, and you have this circuit, and then imagine on that circuit we put like a simple bulb, for example. So we have a bulb on this circuit like so, and then we have a resistor. So we have this section here like so that resists the flow of the electrons. Okay, so we can think about this as this here is a switch. This is a light, or we can just call it an LED, a light emitting diode. And then this here is a resistor. Okay, so what's going to happen is when this switch is up, so when the switch is open like this, the circuit is not closed. So the electrons can't move past the end, can't move past this point. But the minute I close this circuit like so, what's going to happen is it gives the electrons a place to move. So what's going to happen is there's going to be a voltage across this circuit, and that's coming from this positive terminal. Okay, so and depending on how strong that is, that determines the voltage. So what's going to happen is the electrons are going to, they want to get to this positive charge, and the only way they can get there is through this circuit. So they're going to start to move. They're going to start to move through the circuit and around. They're going to move through this LED. Okay, and when they move through the LED, there's going to be resistance. So like we talked up here, and there'll be so much resistance that it'll actually get hot. So think about the particles that make up the particles that are inside this are made of copper, just like here. And what they're actually going to do is they're going to vibrate. And when it goes through an LED, or when it goes through a light, for example, or a bulb, what happens is they will start to give off light. Okay, so you get light, and you get a small bit of heat as well. So what will happen is the electrons will move through here, they'll move through this resistor then as well, but they won't move as easily through it, and they'll move here to this copper, or to this positive terminal. And this essentially is the flow of electricity. Okay, so this is like the flow of electricity, and what we do is we put things in front of the electrons and we get them to do work. So for example, if we put an LED, what will happen is the electrons will move through the material, cause it to vibrate, and then cause it to emit light. We can put resistors in front of it as well, and what will happen is the resistors will get hot. So if you think about the elements inside a toaster, for example, when the electrons move through it, the electrons, they come up against resistance. The atoms that make up the element that's inside your toaster, it gets really hot and it gives off heat. Okay, and that heat then can be used to do useful things like create toast. So you have the current, which is flowing around through this circuit. The current is basically just the electrons moving through the circuit. You have what's making them move. Well, that's the positive force that's on the battery, or that's the voltage that causes the electrons to move around. And then what will happen is there will be a certain amount of resistance, so they will bump against other atoms, for example, that are in the circuit, and they will be resisted to certain degrees by different material along its path through the circuit. So imagine then we have, let's say we have a 2-volt battery. So we have a 2-volt battery, and we have a current of 1 amp moving through the circuit. Okay, so we have this 1 amp and we have 2 volts. So the voltage is like the strength of the battery that's pulling the electrons around through it. And we have 1 amp of current flowing around through this circuit. So what we want to try and think about is like, what would the resistance be? So if we were to measure the resistance at, so the current, for example, and the voltage is going to be the same at each point. But what we want to do is we want to kind of measure the resistance in relation to the current and the voltage. So what we can do is we can take this formula here and we can rearrange it. So if voltage is equal to current multiplied by resistance, then we can rearrange this and find out that resistance is equal to voltage divided by current. Okay, so all we have to do in order to get that is divide both sides by I. That gets rid of the I on this side, and then it just leaves the resistance equal to voltage divided by current. So if we have, for example, then we have 2 volts and we have a current of 1 amp. So if we divide these by each other, you're going to get the resistance, which is going to be 2 ohms, like so. So what we want to think about then is this idea of what's known as Ohm's law. So basically Ohm's law, so if we read this here, the current through a conductor, okay, so remember a conductor is like copper, for example, between 2 points. So for example, the current, imagine if you were to take 2 points. So imagine you were to take this point here and this point here, and you were to zoom in on this point. So what you're going to be doing is you're going to be measuring the current. So the current, remember, is like the number of electrons that are flowing through that point. So the current through a conductor between 2 points, so between these 2 points, is directly proportional to the voltage across the 2 points. So for example, if there's 2 volts, okay, the current is going to be directly proportional to that. So let's think about what does that actually mean, directly proportional. So what it basically means is if we were to draw a graph, okay, so a simple graph like this, and if we had, for example, we measured voltage and we measured current, current. Okay, so current is represented by an I, and then we have voltage. So this is voltage here is represented by a V. So let's say in this case here, okay, so we start off with 2 volts. Okay, so we start off with 2 volts, and what we get is we get 1 amp. Okay, so 1 amp here. So 1 amp. So that's what we start off with. So this is our first point. Now so in this case the resistance. So let's say the resistance is 2 ohms. Okay, so the resistance just stays constant. So when we talk about it being directly proportional, so let's say then if we were to double the voltage, so if we put the voltage up, we took out this battery and we put in a stronger battery that was 4 volts. What will happen is, because of Ohm's law, what's going to happen to the current? The current is going to double then as well. So you're going to get 2 amps. 2 amps of current flowing, okay? So draw a line across like so. So this is this point here. And then let's say we triple it. So we bring this up to 6 volts. And then we measure the current. So what's going to happen is your current is going to be 4 volts, 4 amps, like so. So you're going to get this. So what we can see then is that if we think about Ohm's law, so if we go back to Ohm's law, for example, the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. So we have a conductive material. Let's say this is a piece of wire like so, and we have these 2 points. So we have these 2 points. So what's going to happen is the current through a conductor, so imagine this is your conductor, between 2 points, so between these 2 points, is directly proportional to the voltage across the 2 points. So it's directly proportional to the voltage. So if you have 2 volts and your current is 1 amp, so you have 2 volts across these 2 points, and you have 1 amp of electricity flowing through. If you double the voltage, okay, you're going to double the flow of electrons through those 2 points. If you triple it, you're going to triple the flow of electricity through those 2 points. That's what it means by the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. That is what Ohm's law is. So what you will get then is this like a straight line. Okay, so this means when you get a straight line like this, it means that these two properties are directly proportional to each other. Okay, so you get this relationship between these two observable phenomena of voltage and current, and that is essentially what Ohm's law is. Okay, so that's kind of explaining what electricity is, and then explaining the properties of electricity, and then explaining, for example, what we mean by Ohm's law. So we have this observation between these two um, of current and voltage. Okay, so that is Ohm's law. So what we can do then is we can do something like this, and we can set up like a simple circuit here. So in this simple circuit, you have a battery here. So this is like just a fancy battery basically that we can adjust the voltage, and we can adjust the current, for example, moving through it. So these two guys here then are what are called multimeters, and we can use these to measure. For example, one will measure the current, which is represented by A, and one will measure the voltage, which is represented by V. Okay, this here is a battery. Okay, so this is just like what we talked about. So this smaller side is the negative terminal, and then this longer side is the positive terminal. So what you'll do is you'll get the flow of electricity through this conducting wire. It'll go through this point here, which will measure the voltage, and then it'll go through this point here, which will measure the current. So what we can do then is we can set up our circuit like this, and we can conduct an investigation. And so we can measure, for example, voltage using a voltmeter, or we can measure current using an ammeter like this. And then this is our battery. So with this we can adjust the voltage, for example. And what we will find is that, so basically what we're plotting here, we have voltage, okay, in volts, versus current in milliamps, or in this case, like there's smaller versions of amps. Okay, so and here what we're doing is we're just keeping, so when we've done it here, we've kept the resistance at 1 kiloohm, and here we've kept resistance at 2 kiloohms. And what we can see is we get this straight line basically. So what we have is we have this Ohm's law that the voltage is proportional to the current is going to be proportional to the voltage across the 2 points, and that's what you see here. So you see, as you increase the voltage, what will happen is you'll have this uniform increase of the current flowing through the wire as well. So that's kind of like what it looks like. So again, these are just some like sample data. Okay, so what we have is, so again, we can set up our circuit, and then what we can do is we can adjust the voltage, and then we can measure the current, for example. So we can see that as we start adjusting the voltage, so we start increasing the voltage, what will happen is you'll get this increase in the amount of electricity flowing through, and it's a uniform increase. And then what we can do is we can measure, so for example, we can measure the resistance. So the resistance is going to be voltage divided by current. And then what you can see is that the resistance, it stays the same the whole way through. Okay, so the average of these is going to be 10. So this shows this relationship between the voltage and the current. Okay, and it shows how when you get this uniform relationship between voltage and current, the resistance is the same. So Ohm's law then, so as the voltage increases, the current also increases proportionally as well. So voltage divided by current gives the same value each time, and this is the resistance of the load in the circuit. So this is true only if the circuit stays at a fixed temperature. So that is essentially this relationship here that we've seen and that we have talked about. So what you could say then is that, if you have a conducting material, so basically just in a nutshell, if you have, so this is a conducting material, so at each point in this conducting material, the resistance is going to be the same. So imagine the resistance is just the same. And the flow of electricity, the amount of electrons moving through any point, for example, in this conducting material, is going to be directly proportional to the voltage okay, is going to be directly proportional to the voltage pulling it through. Okay, and that's essentially like that's what Ohm's law is. Okay, so, and you can kind of think about then, so materials that are ohmic materials, what will happen is if you set this experiment up and you measure them, you will get this relationship. Okay, so as you increase the voltage, the amount of current flowing through the wire, for example, will increase in a predictable way. So, but what will happen also then as well is you have other materials that are not ohmic materials. Okay, so things like semiconductors, for example. So if I have voltage and I have current, and sometimes what you might get is something that's like kind of like that. Okay, so these are materials like semiconductors that are not ohmic materials. They don't follow Ohm's law, for example. But metals like copper, for example, are good conductors and they're ohmic materials, so they follow Ohm's law. So it just means that when the resistance is kept, when the resistance is the same across the material, what will happen is the flow of electricity or electrons through that material will be proportional to the voltage on it. Now, not all materials have the same resistance, so different materials will have different resistance. So for example, if you have a filament bulb, for example, like a lot of the old bulbs, like filament bulbs, so the inside the bulb you have this filament material that's made up of a material called tungsten. And what happens is when electrons flow through this tungsten, they are met. It's like it has high resistance. So what will happen is when the electrons go through, they're going to make the material vibrate, and they'll actually make the material vibrate so much that it'll get hot, white hot, hot. And what will happen is it'll get so hot that it'll give off heat, but it'll also give off light as well. Okay, so it'll give off light, and that's for example like how light bulbs work. Okay, so you have uh, this material like tungsten that has a high resistance. If you take other like for example, if you take a kettle, inside a kettle you have like a heating element. So imagine, and what will happen is that element will resist the flow of electricity through it, and as a result of that, it'll get hot. Okay, so it'll heat up, it'll give off heat, and then if that's in contact with like liquid, for example, what's going to happen is the liquid it'll heat up the liquid, so that heat will be transferred from the element into the water, and it'll cause the temperature of the water to increase, or it'll boil the water, so it will. And so you can have materials that have different resistance. So that is Ohm's law, and that is relating the different quantities of electricity, of voltage, current, and resistance to each other. And we're going to look at like circuits and electricity in more detail in subsequent lessons, but just it's to look at the relationship between voltage and current, which is Ohm's law. Okay, thank you for listening.